Hello and welcome to another IB chemistry video with Mr. S. Today we're going to be looking at trends in ionization energy. Now, you should know by now that in IB you need to be very specific with your definitions. And the definition of ionization energy is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms. And that can be represented by the equation below. We've got an element X in its gaseous state, and on the right-hand side, we've removed 1 electron and we formed a positive ion. Now, what is the trend down the group? Ionization energy decreases down a group, and there are various reasons for this. Here we've got 2 elements in group 1, lithium and sodium. Now, the first bullet point here is actually contradictory to saying that the ionization energy decreases down the group. Because as you go down the group, the charge of the nucleus increases because you have more protons as you go down the group. Lithium has 3 protons, sodium has 11, 8 more protons. So that would suggest that there's a greater attraction between the nucleus and the outer shell electron. And therefore, the trend you would imagine would be the opposite, an increase down the group. However, there are other factors into play. Now, as we can see here, between the nucleus of lithium and the outermost electron, there is only 1 shell and 2 electrons in between. Whereas for sodium, there are 2 shells in between, more electrons. And because those electrons are there, the outermost electron doesn't feel the same attraction to the nucleus. And this effect is called shielding. So the shielding increases as you have more energy and shells. Okay. Now, of course, as we've talked about in the previous video, the distance between the outer shell electron and the nucleus increases, and therefore the electrostatic attraction between the nucleus and the outer shell electron decreases. So that explains why going down the group, the ionization energy actually decreases. So it's easier, to remove an outer shell electron. Now, what is the trend across the period? It increases, ionization energy increases across the period. Taking 2 example elements, sodium and magnesium. Main difference here, 1 more proton, 1 more electron. So as you go across the period, the nuclear charge increases. So 11 to 12 protons. More protons, greater attraction to the outer shell electron. Now, in the previous trend, we talked about how shielding affects ionization energy. However, there's not a great increase in shielding because any electrons you add across a period are in the same outer shell as the previous one. So that doesn't contribute as much to the shielding. So ionization energy increases across a period. Okay, I hope this has helped. Please watch the second part of this video to see some exceptions to this trend of ionization energies across a period.